Okay, the test is written. It's 50 questions, 5 points each. It'll be 250 points. We're going to go over a few more things. Some of this may be a repeat from the first video, which I made last week. This video I'm actually making Sunday night. Your test is coming up on Tuesday. Okay, so these two videos today, you can watch on Monday, will be a great review for you. But make sure you read through your notes. Okay, some of the questions, you need to find the answers in your notes. All right, now don't worry too much. In fact, you really don't need to worry much about uses at all, except for some of the allotropes of carbon. Okay, when we talk about allotropes, remember it's the same element in different structural forms. So there's three different allotropes of carbon. You've got buckyballs, right, which kind of looks like a soccer ball. You got diamond and graphite. Okay, graphite is very soft. It's used as a lubricant. Right, you're right with graphite. Diamond is very hard. Okay, it's also pure carbon. Diamond, graphite, and buckyballs are all pure carbon, just in different structural forms. Okay? All right. Let's talk about the periodic table. You will have this sheet right here for your test. Okay? So you're looking at it right now. You can look at it for this video. It's going to help you out a lot. Okay? I'll hand this out when we start the test. You'll be welcome to write on it. I will want it back. You turn it in when you're finished with your test. I'll come around and collect them, and I'll just recycle them. Okay, I'll make one for everybody, so you don't have to worry about not writing on it. You can write on it to your heart's content. All right. First of all, let's look at this stair-step line. Okay, this bold stair-step line right here. Elements that fall along that stair-step line are metalloids. All right, with the exception of aluminum. Okay, aluminum is still a metal, but boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine would all be metalloids. Okay, anything to the left of that line, we call that a metal. Okay, over here is a metal. Now these guys are actually called the intertransition metals. They fall right in here. Okay, we'll talk about them again in a minute. Over here to the right of the stair-step line, okay, but not touching that line, these are your nonmetals. Okay, now if you want to know the properties of metals, nonmetals, metalloids, read the notes. All right, you'll need to know some of those for your test. Okay, what are properties of metals? What are properties of nonmetals? You need to be able to determine whether it's a metal or non-metal based on properties. Okay, and the metalloids have some metallic properties and some non-metallic properties. Okay, they're kind of a blend. Now, one very, very important metalloid is silicon. Okay, silicon is used in a lot of semiconductors. And a semiconductor is something that can conduct electricity under certain conditions, right? Well, if we want to be able to control the flow of electricity and use it, harness it for making computers and things, we need to really be able to control the conductivity. And semiconductors allow us to do that. All right, so silicon is a very important semiconductor. All right, let's talk about bonding. When you have, actually, one more thing. Nonmetals are over here with the exception of hydrogen. Okay, hydrogen is a nonmetal. It is in group 1 because it has one outside energy level electron. All right, and it's going to sometimes behave like these alkali metals in chemical reactions. Okay, sometimes behave like these alkali metals. All right, it is classified as a nonmetal. All right, if you look at the back side cover of your book, you'll see it is a nonmetal. All right, now bonding. Okay, our metals, when they bond with other metals, let's say you have iron and cobalt, right, or titanium and chromium. Okay, these are going to bond through what are called metallic bonding. And we talked about this, it's in the notes, but basically you have these small, dense, positively charged nuclei with inner shell electrons around it, and then you have the outside electron that are free to move, okay? And because they're free to move, we call it a sea of electrons that are surrounding the rest of the atom, okay, the rest of the metal atom. That sea of electrons allows them to form metallic bonds. All right. Now, an alloy is when we mix two different metals together, right? Like iron and nickel, or say zinc and tin. Okay, we make alloys. All right. So metallic bonding occurs between two metals. All right, it could be this two metal atoms. It could be the same element. It could be different elements. Okay, it's a metallic bond. Ionic bonds form between metals and nonmetals. All right, And ionic bonds, remember, are when electrons are stolen. So the nonmetals really like electrons, and they're going to steal electrons from your metals. When they do that, these guys are going to become negative, and these guys over here will become positive. All right. A metal-nonmetal bond is called an ionic bond. It results, or it's caused by the stealing of electrons. All right. The nonmetal steals electrons from the metals, and then because you now have a negative ion and a positive ion, they attract, right? And it forms a nice strong bond. Okay, that's an ionic bond. A covalent bond occurs between two non-metal elements. So like oxygen and oxygen, O2, it's a nice covalent bond. But you can also have like sulfur dioxide, right? We could have carbon dioxide. We can have carbon, tetrachloride, and other non-metal bonds. Okay, a non-metal bond is called a covalent bond, and they are sharing the electrons. Okay, it's key word. Shared electrons are in covalent bonds. Stolen electrons are in ionic bonds. Okay, in the metallic bonds, you're looking at a sea of electrons that kind of float from one atom to another. All right. Since we're talking about things like O2 and F2, let's talk about diatomic molecules. Okay, diatomic molecules are the same element, and you have two atoms of that element bonded together to form a molecule. And that is the way that hydrogen gas exists. Okay, it exists as H2 in nature. That's the way that nitrogen gas exists, N2 in nature. That's the way that oxygen gas exists in nature, O2. Okay, so our atmosphere is mostly nitrogen and oxygen, right? Fluorine gas, again, F2. Chlorine gas, Cl2. Bromine, which is actually a liquid, is Br2. And iodine is actually a solid. It is I2. Okay? So we have 7 diatomic elements in nature. We call them diatomic molecules. All right? We've got hydrogen, and then over here they make a little L-shaped. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so those 7 elements. There's 6 here. 1, 2, 3, 4, 5, 6. And 7 is hydrogen. Now your noble gases, which are over here in group 18, they actually float around in nature as individual atoms. Okay, those atoms are very chemically stable because of a full outside energy level of electrons. Okay, helium has 2, all the rest of these guys have 8 in their outside energy level. All right, so neon has 2 in its first level, 8 in the second level. Argon has 2 in the first level, 8 in the second level, and 8 in the third level. Krypton, right, down here is going to have 2, 8, and then it's going to have actually 18, okay, because these 2, those 6, and these 10 right here actually go into the third level, all right? So it's going to have 8 in its fourth level, okay? 8 in the fifth level, 8 in the sixth level, all right? So these guys all have 8 in the outside energy level. This guy has 2. Now, when you think about energy levels, think of these electrons are closest to the center of the atom, all right, closest to the nucleus. These guys are the next closest, all right, level 2. Level 3, another step out. Level 4, another step out. Level 5, another step out. Level 6, another step out, okay? And then there'd be level 7. Now, these are not level 8 or 9, okay? These actually go lower. So these would be level 5, and these would be level 6, all right? Okay. All right, so we've covered bonding. Let's go over the groups and group names one more time. Okay, we need to know this. There's going to be a lot of test questions about this. All right, anything in group 1 is called an alkali metal. All right, except for hydrogen, it's a nonmetal. Okay, but these elements here, group 1 elements, are alkali metals. All right, group 2 elements are alkaline earth metals. All right. Groups 3 through 12, this whole block here is called the transition block. We call these transition metals or transition elements. All right. Now the ones down here, okay, these guys come after lanthanum. We call those lanthanides. And these guys come after actinium. We call those actinides. Now, if you put the lanthanides and actinides together, this whole block down here is called the inner transition metals. All right. So you've got the transition metals and the intertransition metals. And over here, we haven't really talked about this, but after the transition elements, there are some post-transition metals. They're gallium, indium, aluminum, thallium, tin, lead, and bismuth. Okay, And then germanium, antimony, and polonium are metalloids. These guys here are metalloids, right? And then we get to the nonmetals, right? The only groups you need to know, though, by name are your alkali metals, alkaline earth metals, transition elements. You need to know the lanthanide series, the actinide series. You need to know the halogens in group 17 here, and you need to know the noble gases in group 18 here, okay? You don't need to know the names for these groups here, okay? Even though this is called the boron group, carbon group, nitrogen group, oxygen group. Okay, now let's talk about the ions that these different groups want to form. Okay, for this you need to know 4 of them. Okay, everything in this column here in group 1 wants to form a 1+ ion. They have 1 electron on their outside energy level, and they would love to lose it to become more electrically stable, all right, more chemically stable, like a noble gas. Anything in group 2 would like to lose 2 electrons to become like a noble gas. All right, your noble gases, they don't want to react with anybody. They've got all the electrons they want, and they're happy to stay that way. Okay, now in group 17, they want to gain 1 electron to become like a noble gas. Okay, so they become 1- ions. Now your oxygen group, they pretty much want to gain 2 electrons to become like a noble gas. And then all these other guys, right, 3 through 15, we're not going to worry about those. All right, don't worry about those. Yeah, you deal with that in chemistry, not in physical science. All right, same thing with these. We're not going to worry about these down here. Okay, for ions, we're going to talk about +1, +2, -1 in 17, -2 in 16. All right, in group 18, they don't want to form an ion. They're very happy the way they are. Okay, a couple more things. I want to say again, an alloy is 2 different metals blended together. Okay, an alloy is 2 different metals blended together. Now, we should talk about the iron triad, which is iron, cobalt, and nickel. Okay, these 3 guys right here, iron triad. Okay, they are magnetic. Okay, they're important elements to know. The coinage metals are copper, silver, and gold. Okay, in a vertical column right here. Those are important to know. Right, we've used those as for money for years and years and years. Right, copper, silver, and gold. Coinage metals, iron triad, iron, cobalt, nickel. These guys are magnetic. All right, the most abundant metal in the Earth's crust, I believe that's a test question, is aluminum. Okay, that's the most abundant metal in the Earth's crust. The second most abundant metal is iron. All right, the most abundant element is actually oxygen. Okay, but it's a non-metal. All right, so most abundant metal, aluminum, most abundant. Second most abundant metal is iron. The most abundant element is oxygen. Okay, now synthetic means something that is not naturally occurring on Earth. Something that is synthetic is something that is man-made. There are 2 elements aside from the transuranium elements, okay, beyond uranium, right? More than 92 protons. These are transuranium elements. All right. There are 2 elements besides the transuranium elements that are synthetic. They are technetium, right here, number 43, and promethium, which is right here, number 61. Okay? So technetium and promethium are synthetic. You'll need to know that for your test. Okay. Again, I just want to urge you guys, read through the notes. Okay. I can't stress enough. You need to read through the notes. Okay. Don't worry about, what is this element or that element used for. That's really not the main point. Okay. Look at the properties. Look at, what's a nonmetal and metal. Look at the stuff we've talked about today, the groups and the group names. All right. Those are things you really need to know. I know you guys can do well on this test. Just study. I hope these reviews have been very helpful. I know that I've written the test. I've looked through it. I made sure that in these 2 review videos, we've covered, the questions that are on the test. All right? Great. Okay. I'm going to close with this right here. C19 notes, right? You can get the note outline key and my handwritten notes for each section of chapter 19. These are the things you need to read through. Okay, study. Watch this video, 2 videos. Maybe I'll post them on YouTube so you can watch them again if you want to. But read through these note outlines, all right? And then you can also check. You can also check the section 1 quiz, section 2 quiz, section 3 quiz, homework 1, homework 2, homework 3, homework 4, and homework 5. Okay, I've pulled all the test questions out of those. All right, I didn't write anything other than what's already in there.